Okay, this comes from 4, 4. That looks good. Let's do this again right here. One other thing. I'm gonna close all these tabs. And we have somebody join. I'm coming, guys. It's just getting a little bit organized. Look at these students. Where'd it go? There it is. This one. All right, let me, now the moment of truth, let me share my screen. Where is it? Let's stop that share. Let me share my screen, start the broadcast. Right, let me now optimize for that. We'll go there. Okay. And then let's start here. Where did I go? I gotta reload that again. Okay. It's this one. Perfect. Right here. This. Yeah. Share. Okay, so it looks like my screen is sharing properly. So I'm going to move forward. Okay, so this first question comes from section 4.4, question 11. We're asked to find the area of the shaded region. Okay, that one. Let me think about it. So we got our f of x as x goes from, what is that, a -2 to 4. Okay. Okay. So let's get a copy of this and let's take some notes. Here, here, copy and delete. All right. And paste. Yeah, sorry if my energy is low. Like, I think I just have not recovered from the time change. I think it's a little bit of the time change and getting older, and then just other energetic things that are going on. But anyway, let's keep going. So we're asked to find the area of the shaded region, right? So basically, they're asking us to find the definite integral, right? So they're asking us to find the integral. You need to be charged. You should need to be. Okay, that should be enough. So let's see, they're asking us to find the integral as x goes from -2 to 4 of, now g of x equals 0. Yeah, we should be okay. -2 to 4 There's one other thing that we might need to adjust. I'm just gonna try what my first mind is telling me, and then if it doesn't work, there's something else we can try. It's x goes from -2 to 4, and I think it's just the 10x plus 3x squared minus x cubed. Okay, dx. Okay, I think this is fine. Mm-hmm. Okay, so then if we integrate, this is going to be equal to what? The first one is 10x squared over 2, so that becomes 5x squared. The next is going to become 3x cubed over 3, so then that's going to become just x cubed. The last one is going to become negative x to the 4 over 4. And we want to evaluate this as x goes from -2 to 4. Okay. So then we plug in 4, we get an answer. We're going to say minus when we plug in -2 and we get an answer. I think for that, I'm just going to use my calculator. So if I go like this, right here. Reload and refresh. That looks good. Okay. So in my y equals, I'm going to put this 5x squared plus x to the power of 3 minus x to the power of 4 divided by 4, right? For me, this is just a little bit easier to do it this way. So then I'm going to call on that function that I just typed in. I want it evaluated when x is 4. I'm going to say minus. I think this will work. Again, we might have to make an adjustment for this next part. We need to plug in when x is -2. Okay. So then we get a result of 72. Okay. So we're gonna go with that. Let's just see what happens. So can I get rid of this? I didn't want to close all of them. I just wanted to close that one. Oh no. Did we close everything? So okay. I think I can pull it back up. Let me share. And I want to say the number should be the same, so we shouldn't have to do it over again. It looks good. I'm going to put 72 and go with that. Yeah, we did that. Even if we said f minus g, because g is 0, if f is greater than, then the area between the regions is going to be this. To divide the integral into subinterval is needed. Use this theorem. So the only difference is, okay. So the only other thing I could think, that's why I was kind of pausing for a moment, is that negative portion, right? So we might need to break it up into 2 parts, because when x is positive, f is above g, so we can say f minus g. But when x is negative, g is above f. So then it looks like we need to do g minus f. Okay, so let's account for those changes for that narrative. That's why I was kind of hesitating. So let's account for those changes. All right. Again, we do need to say f of x minus g of x, but that holds whenever f is larger than g, above g, when f is above g, right? So to account for that change, we're gonna break this up. Instead of going from -2 to 4, I think that's 4 is what they want. We're gonna go -2 to 0 and then 0 to 4. All right. Okay. So let me strike through this for right now. Oh, like this. Okay. And so if they want the area under the curve, or if they want the area of the shaded region, let's do the integral as x goes from -2 to 0. And there we're going to do g minus f. We're going to say g of x minus f of x, because when as x goes from -2 to 0, g is above f, right? So we're going to do this one. We're going to do this first, dx, okay? And then we're going to say plus the integral as x goes from 0 to 4, and I'm hoping that they want the 4 and not the 6, because the shaded region goes up to 4. Now f is above g, so we're going to say f of x minus g of x dx. All right, so I think that's the change that we needed to account for. Okay, so if we continue this narrative, this goes from -2 to 0. So g of x is the 0 function, and so we need to distribute a negative into f. Okay, so what was that, 0? So then this first part is going to become -10x plus 3x squared. Distribute the negative. So minus 3x squared plus x cubed. All of that's, we need a dx like this. And then we're going to say plus the integral as x goes from 0 to 4. If we say f minus g, then that's just going to be the 10x plus 3x squared minus x cubed dx. Okay, so I think that's the change that we needed to make. It looks okay. So now let's evaluate these combined integrals. So the first one, negative 10x squared over 2 becomes negative 5x squared, x cubed over 3. So that becomes just negative x cubed, and then plus x to the 4 over 4. Okay. We want to evaluate that as x goes from -2 to 0. And then we're going to say plus, let me see, x squared over 2. So that becomes 5x squared. And we can even kind of do it like this. Okay. X squared over 2, x cubed over 3. So plus x cubed minus x to the 4 over 4. And we want to evaluate that as x goes from 0 to 4. Okay. So let me check out my calculator one more time. Oh, maybe I lost it because let's go like this. Full screen. Let's break this one off. Okay, I'm gonna hop back. Over here, calculator at that point. So I guess we don't have our y equals anymore, but we can just use the one that just, the only difference between the left one and the left expression and the right expression is a negative. So I'm just going to put it in once. 5x squared plus x to the power of 3 minus x to the power of 4, parentheses, x to the power of 4 over 4. Okay. All right. So for the first one, let me think about it. If we factor out the negative, okay. Just so I can be more confident what I'm going to do, because I was going to multiply by a negative, but I'm getting a weird vibe from it, like it might do it out of order or something like that. So instead, I'm just going to go ahead and make another, insert the expression again. So let me insert a negative here. So I'm going to insert a negative here. I want that to go from positive to negative. And that needs to go from negative to positive. Okay. So there's the first one, and then now we're going to put the second one here. And I'm going to just have it in there twice. 5x squared plus x to the power of 3 minus x, let's do parentheses, parentheses, x to the power of 4 divided by 4. Okay. I think that's okay. Okay, let's quit. So then, so I want to call in that first function, and I want to evaluate it when x is 0. And we're going to say minus, calling on that first function again when x is -2. Okay. Then we're going to say plus. Now I want to call on the second function when x is 4. I think we're okay. We don't need to distribute any negatives or anything. So I'm going to say minus the second function when x is 0. Okay. I feel like those are all the components that we need. We got 88 this time. Okay, hopefully we made the proper changes. I feel better about this than I did about the first one. Guess I could have been charging my pen while I was doing all that other stuff. I just want to write 88 and I'll just put it back on the charger. Okay. So this time we got 88. So we're gonna try that one. If that doesn't work, then you know, I feel like, again, I feel better about this one than I did the first one. That's why I kept pausing. I was like, I think it's okay. We got 88, so let's try 88. Oh, no. Let's do it like this. Off. Cross our fingers. Okay. So to kind of like, for that one, that was a good one because that's why I kept hesitating the first time, because I was like, I think we need to account for that negative, but it was good that we did it the way that we did, right? Initially, we tried to integrate as x went from -2 to 4, but that negative x was kind of throwing things off, right? When we were working with negative x, we needed to say g minus f because g was above f, right? So that made, we had a negative that we had to account for. And then when, for the positive x, as x went from 0 to 4, f was above g, so we just said f minus 0, so that was more straightforward, right? So we definitely had to account for that negative for it to work out properly. I think the way that we did it, we said the positive part right, and then I think we subtracted the part on the left, and that's why we got 72. Where once we set it up properly, we ended up adding instead of subtracting, right? Because there was like a double negative thing going on there. Hopefully that made sense. If we need to kind of recap that, we can. Let me pull up the next question. Yeah, I like these. Okay, let's do another one. So this next one looks like it also comes from 4-4. I gotta clean. This dog is like, ugh, it's incessant. It's like so much right here. Oh, I forgot about that, but that's okay. It's just full screen for right now. Matter of fact, let me get rid of this. Get rid of that one. All right. Set up and solve. Find the area of the region bound by the graphs of the given equations. So one graph looks like it's y equals x. The other is y equals x to the power of 5. And we want to evaluate x as x goes from 0 to 1. Okay, we can do this. So I think I'm gonna just work out the whole thing and then I'll come back and fill in the parts. All right. So let's start by getting a screenshot. And we only need it from like about there to here. Okay. I'm going to copy and delete. Let's hop over here. Start a new page and expand it so the folks at home can see. Boom. Okay. All right. So this one, now that we've kind of had the experience with the previous, this is similar, right? Find the area. So, when we're doing this integral, we need to say the top function minus the bottom function, right? So we're going to take the integral as x goes from 0 to 1. Now the top function looks like it's y equals x. So we're going to say x minus x to the power of 5 dx. And I think that's the setup there. All right. Okay. I think those are all the components there. So then if we go ahead and integrate, that becomes what? X squared over 2 minus x to the 6 over 6 as x goes from 0 to 1. So when we plug in 1, we get what? 1/2 minus 1 over 6. We get an answer there. Then we're going to say minus. When we plug in 0, it looks like we get just 0. Okay. So then this is what? 3 over 6 minus 1 over 6 equals 2 over 6 equals 1 over 3. Okay. That one looks like we get the third. I feel pretty okay about this one, so we're gonna go with it. Okay, set up the integral or integrals that will give the area of the region. So we're gonna 2. Why is there a 2? Let's see. Is there something else that we're missing? One, two, three, 4. I don't understand what they're going to. Oh, okay. It's multiple choice. I was like, what is going on here? I had to change my settings so I can see the whole thing. Let me zoom out some. I was like, that is not right. Okay. That's why I wasn't right, because I was looking at one of the wrong multiple choice questions. Okay. Let me zoom out a little bit more. All right. Yeah, I was like, what is going on? I was like, there's nothing to there. Okay. Anywho. So this is what is x goes from 0 to 1, and we only had one integral, so we're gonna go with C. X goes from 0 to 1, and I think we had x minus x to the power of 5. Okay, that looks good. That's exactly what we had when we did it. Let's check our answer. Okay, so then we got an area of what, like 1/3? 1 over 3. Okay. Okay. Guess that was it for that one.
Yeah, it was 1 over 3.
Sure. Have you sent it already?
No, I'm saying, yeah, the area was 1 over 3.
Mm-hmm. You said it. When you said a third, I thought you said one more. But yeah. So yeah. I'm just going to go ahead and mute myself, and I'm here if you have more questions. And also, you can ask questions from your exam too. Like if you're working on your exam now and you're stuck, or if you want some assistance, you can actually ask questions from your exam as well. Okay. And also, like as you kind of work through this, go through this material on your own, feel free to take this content. You can like sit down with the tutors and go line by line. You can work with them as well. That's okay as well. Anything that's on Pearson, if it's on Pearson, you can just take it and work on it with them. I'm going to suppress my audio and just unmute yourself to get my attention if you need me. Okay, welcome scholars. If you're just joining us, I'm just using today as a Q&A. We've gone through 2 questions. I am live streaming the session, so you can always go back and see what we did together. So far, we've only gone through two questions, but I'm using today. So we just got another question. Let me pull it up. If you don't have any questions, you're not obligated to stay. You're welcome to stay if you like, though, but you don't have to. Just make sure everything is in order, and I'm here. Let's work on this first one.
Morehouse.
Share the tablet. Okay. So this first question we have at least a set of 2. It says find the area of the region bound by the graphs of the given equations, right? So we have y equals x, and then we have square root of x. So then I want to say the square root of x is going to be above y equals x. For instance, let me see, when x is 1/2, y is 1/2. But the square root of 1/2. Oh, wait a minute. Okay, so let's look at the graph. Let's look at the graph. I'm trying to think, because I know they cross at 0, 1. The simple thing here is just look at the graph. Do I have one? Oh, is that this one? Okay. So let's pull this up. Okay. And so what I'm going to do, and we could do Desmos as well, or GeoGebra if you don't want to see this virtual calculator. We can do Desmos because Desmos is free. So I know a lot of students use that as well. What I'm going to do, I'm going to basically plot both of these. Y equals x, and then I'm also going to plot y equals the square root of x. And so as we saw in the previous couple of examples, when we go to integrate the region bound by these graphs, we need to say the top function minus the bottom function, right? So if we look at the graphs, we might need to zoom in to see it. Let's zoom in some. But it should be the case that square root is above. Why is it not like, let me go window. X min, let's go negative, like -1. X max, let's go, we need to go like to about 2. The scale, let's go by 0.25 on the x-axis. The y minimum, we can go like -1. The y max is like 2. Y scale, we can do 0.25 as well. Okay. Let's hit the graph. So that's y equals x. Yeah, square root of x, right? And they cross when x is 1. Hey Siri, what's the square root of 1/2?
The square root of 1 divided by 2 is approximately
0.7. Yeah, right? Yeah, okay. So yeah, when I did it in my mind earlier, it was kind of throwing me for a loop, but that makes sense, right? So the square root of 1/2 is root 2 over 2, right? Which is like 0.7, yada, 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 which is larger than 1/2, right? So long story short, as x goes from 0 to 1, the square root of x is above y equals x, right? Okay, so I think we have everything we need to kind of to do this one. Let me just zoom in some. Okay, and let's get a screenshot. So again, the main thing is we need to be clear which function is above the other, which we are now because we looked at the graphs. We're going to copy and delete. Let's go here. And we're going to drop the image right here. Okay. All right. So let's crop this a little bit. Crop. That's better.
Professional.
Yes.
You said the square root of x is above the first equation.
Only when x is between 0 and 1. Once we get on the other side of 1, then it reverses.
Okay.
So we're only focused on the region from 0 to 1 because that's where, you know. I think I'm only focused on 0 to 1 for right now. So let's try. The integral as x goes from 0 to 1. We said square root was above, so we're going to say the square root of x minus x dx. Okay. So then this integral, square root of x, that's going to be what, x to the 1/2. So then it becomes x to the 3/2 over 3/2. Minus x squared over 2. We want to evaluate this as x goes from 0 to 1. Okay. So then when we plug in 1, we get 1 over 3/2, which is really just 2/3 minus 1/2. And I think that's it because when we plug in 0, all those terms are gone. So then, common denominator, we can say is what, 6. So that becomes what, 4, and that becomes 3. So then we get 1 over 6. I think that's it. 1/6 of the unit. Okay. Or 1/6 units squared. We got 1 over 6. I think we had another one, so I'm gonna go ahead and pull that one up as well. Okay, right here. Where is it? We want to share right here. Okay. Find the area of the region bound by the graphs of the given equations. Y equals 2 and y equals the 4th root. Okay. Wait a minute. Equals 2. Y equals the 4th root of x. Okay. Okay. Okay, so let's start by let's look at these graphs, right? So for instance, we got y equals 2. I'm going to kind of ignore the x equals 0 for right now. We got this 4th root, so we have what? X, 4th root of x is the same as x to the power of 1 over 4. Okay. So these two are going to be equal 16. Is it sooner than that? When x is 0, I think it's when X is 16, right? That's when they're gonna cross. Let's look at the graphs. Let's do my window. Let's start off with the standard window. Zoom standard is 6, but we might have to zoom out some because we got our y equals 2. Yeah. Okay, I want to say they cross. Oh, okay. So I want to say these two graphs cross when X is 16, right? So you can kind of get a sense from here. Here, let's do a better window. So our X minimum, we can go down to like maybe X is -2. Let's go up to X is 20, and let's go in steps of, I guess we can go 4, because we just want to see where it crosses at that 16, right? 4 should be okay. The Y min, we could say like -2. The Y max, we could say like maybe 3. And the Y's, let's have them change by 0.5. Okay, so when we look at the graph, there's Y equals 2. There's the 4th root of X, and it's crossing at 16, right? Because remember, the X-axis went by 4. So we want the region bound by Y equals 2 and the 4th root of, Y equals 2 and the 4th root of X. And also it looks like we want X to go from 0 to wherever they cross, right? Again, they cross when X is 16, so it looks like we're going to integrate as X goes from 0 to 16. And it looks like Y equals 2 is above the 4th root of X, right? So with that, I think we have everything that we need. So I think what I'm going to do, I'm going to include this image. I'm going to screenshot it like there. Hopefully that worked. Okay. And I'm going to take this. I'm going to take it to about there. That's decent. Okay. So we're going to copy and delete this. And we're going to drop it right here. Okay. Paste. All right. So now, again, it looks like this integral, we're going to integrate as X goes from 0, they cross at 16. The one that's on top is what? Y equals 2. So we're going to say 2 minus the 4th root of X dx. Okay. And that's going to focus on that shaded region, or that region that's bound by these equations, right? I guess we can do it in blue. It's basically this region here. Okay. So that's what we're finding the area of. Okay, I think this is okay. Let's give it a go. Okay, so then this is going to become what? 2x. Now remember, that's x to the power of 1/4. So then it's going to become x to the power of 5/4 divided by 5/4. We want to evaluate this as x goes from 0 to 16. Okay. Okay. So then when we plug in 16, we get what? 32 minus, I want to say the 4th root of 16 is what? 2? Yes, right? So then 2 to the power of 5 is 32. So then we're going to have minus 32 over 5/4, right? And I think when we plug in when x is 0, those terms cancel. If we flip and multiply, okay. So it looks like a common denominator is 5.
That's it.
Yeah, yes.
How'd you get x to the 5/4 power over 5/4.
Right here, right? So we have this fourth root of x. That's the same as x to the power of 1/4. So then when we integrate, we're adding 1 to that power. So then 1/4 plus 4/4 gives us 5/4. Then we got to divide by the new power. Okay. Let me see if I can get this number. So the common denominator looks like it's 5. Let me see. So 5, that's 150. So I think that's 160. Minus 4 times 3 is 120. 128. Okay. That's 30. That's what, 32/5? We could probably leave it like 32/5. Okay. Let me try this. Let's see. 30, we get 32/5. This one. Let's close that out. Simplify your answer. We got 32/5. Let's see. 32/5. Okay. Do I need to go back over any parts of that? So we got it correct.
No.
Okay. Okay. All right. So I'm just gonna suppress my audio. And again, if you have other questions, I'm here.
Professor.
All right, let's see what we got here. So I know you said 2 was the other one. I think we did this one already. Okay, let's do this one. Okay. So this one comes from 4 question 41. It says determine the average value of f over the interval as x goes from a to b, where f of x is this, a is this, and b is this. I'm assuming they just want us to take the integral of f of x as x goes from 1/6 to 6. So the integral of 1/x is the natural log, right? So it looks like it should just be the natural log of, let me write it out. I think it's just the integral, right? View an example. Oh, average. Okay, so 1/b minus a. So it is the integral, like we were saying, but we just need to include 1/b minus a. That's the only thing we're missing. Okay. All right, so let's get a screenshot. Copy and delete. Weird. Even like that. I got some kind of something. Right here. So let's paste. Okay. So average value, I'll do this in green since it's a formula. 1/b minus a times the integral as x goes from a to b, f of x dx. I think that's it, right? I'm going to go with this for now, and we'll adjust if we need to. So then we're going to have 1/6 minus 1/6, okay? Times the integral as x goes from 1/6 to 6 of dx over x. An integral of 1/x is the natural log. I think this is going to be 1/30, right? Let me see if I say 6. 36. So that's a 35. 6/35, right? I think that's 6/35. Times the natural log x as x goes from 1/6 to 6. It's going to be 6/35 times the natural log of 6 minus the natural log of 1/6. I'm just going to go with this like this for right now. Let me think. So I feel like we can break this apart into the log of 1 minus the log of 6. So then it's really going to be 2 times the log of 6. I think that's what it is. It said type an exact answer. Okay. So if that's 2 times the log of 6, then that's 7 and 5. So we could say 12/35 times the log of 6. I think that's it. Okay, so one thing let me just do a little bit of a check. Let me use my calculator just to confirm some of these calculations I did. Now it acts like it doesn't want to open. There we go. Okay, let's reload and refresh. So one thing I want to check, if I say 1 divided by 6 minus 1/6, okay, I'm going to hit math as a fraction. We should get 6/35, okay? Then I want to say basically that answer, I want to say times the natural log of 6 minus the natural log of 1/6. We should get like some decimal. And then I just want to confirm that our answer gives us the same decimal. So if we did 12/35 times the natural log of 6, we should get the same decimal, right? Okay, so that makes me confident, at least more so confident in the result that we got. Okay, let's try that one. 12/35 times the natural log of 6. Okay, 12/35 times the natural log of 6. Okay. Did you just send 2 or did you send 1 recently in that last set?
I think I sent just one.
Okay.
Yeah, Professor, I have a
Yes.
question. Where did you get the natural log of x and the 12/35 from?
Say in the beginning.
Yeah.
Say that question one more time.
Where did you get the natural log of x?
In the beginning.
Yeah.
So, okay, so normally we add 1 to the power. The only one that's an exception to the rule is when we're trying to integrate x to the -1. In other words, when we're trying to take the integral of 1/x. That by definition, the integral of 1/x is natural log. Right? So the integral of x to the -1, that's the exception to the rule. The integral of that guy is the natural log of x. The others, anything, as long as the power is anything other than -1, then you can add 1 to the power and divide by the new power. But if that power is -1, when you take the integral, that's going to give us the natural log of x. So that's where this log x came from.
Okay. Also, where did you get the 12/35 from?
Okay. So with that one, let's take it from right here. I'll do this in purple. So this guy here, the natural log of 6, I just left that one alone. But we had this natural log of 1/6. So I think earlier we said what is it? The log of the product becomes the sum of the logs, and the log of the quotient becomes the difference of the logs. So we have a log of a quotient here. So we're gonna have minus, we can break that log of 1/6, we can break it up into the log of 1 minus the log of 6. But the log of 1 is 0, so this guy goes to 0. Double negative becomes positive, so then that becomes 2 times the log of 6. So then I said 2 times the 6/35 to get the 12. Okay, guys. So let's try to hang out for like at least 10 more minutes, give or take a few minutes. I'm going to suppress my audio and just, get my attention if you need me.
Morehouse? Morehouse?
Okay, so we got a couple more. Let's see what we got going here. So this comes from 4-4. This looks kind of intense. Let's open it here. Oof. Okay, it says the concentration of phenylbutazone in micrograms per milliliter in the plasma of a calf injected with this anti-inflammatory agent is given approximately by this guy, where T is the number of hours after the injection, and T ranges from 0 to 110 hours. Given that the model is accurate for 0 to 110, what is the initial dosage? What is the average amount of phenylbutazone in the calf's blood for the time between 5 and 110 hours? The initial dosage. Let me see. The concentration. So basically, when time is 0, is that right? Let me see. The concentration of this. I'm tempted to just let T be 0 to get the initial dosage. If we let T be 0, it's 42.87 micrograms per milliliter. So basically I'm saying like when time is 0, I just plug in t equal to 0. The exponential becomes 1, right? Because it's going to be to the power of 0. So it's a 1. Only thing that's left is at 42.87. Type an integer or a decimal. I'm going to put 42.87 for the first one. All I did was let t be 0. 42.87. Okay, so again, all I did there was just let t be 0. And then the average amount, so we're going to use that the average, like we did before in the previous example, between 5 and 10 hours. So we're going to say the integral, we need to do 1 over b minus a times the integral as t goes from a to b of c of t dt, right? Okay, let's get a copy. Right here. Okay. Let's see. So again, we're using the average value function or formula. So we're doing 1 over b minus a. So 110 minus 5 times the integral as t goes from 5 to 110. C of t is 42.87 e to the negative 0.01055 t dt. Okay. Yeah, we got our negative, right? So, you know, this 42 can just go in front, right? Because it's a constant, so you can just kind of ignore it, just move it to the front to make it more simple. So we're gonna have this 42.87 over 105 times the integral as t goes from 5 to 110 e to the negative 0.01055 t dt. So the integral of e is itself. I think we need to say divided by the divided by that coefficient, right? So when we integrate this, we should get 42.87 over 105. It should be e to the negative 0.01055 t divided by negative 0.01055 t. Not t, just like this. All right, and then the way you can tell is you check by taking the derivative. Man, something is like, I don't know what is going on. Something bit me. Anyway, right? If we take the derivative of this guy, we're going to get itself back times the derivative of the power. So that way these guys are going to cancel and we'll finish with what we want. All right. And we need to evaluate this as t goes from 5 to 110. Okay. So I think what I'm going to do is use my calculator. Full screen. Everything's a little bit topsy-turvy here. Let me reload and refresh. Okay. Pull this up. Y equals. So I'm going to put E to the power of negative 0.01055x, close parentheses, divided by negative 0.01055. If that's okay. Okay, so I'm going to quit. Then I'm going to say 42, here, let's use some parentheses here. 42.87, that's not a 7, divided by 105, okay? Now we're going to say times, I'm going to use parentheses. I want to call on that function that I just put in, and we want to evaluate it when when x is 110. And then we're going to say minus that same function, but when x is 5. So I'm going to do that, and whatever answer I get, I'm going to multiply it by that coefficient. This is the number that I get, okay? So if we hop back over here, this one, round the final answer to decimal places as needed. That might throw us off, because if they're rounding on the intermediate steps and I'm not, that means our results are going to be different, right? So we might have a hard time getting this one right. I would have to go back. I'm just going to kind of go with this for right now. And I might just let it be wrong because I think we're going to be close. 2 decimal places is going to be 59. So 24.59. Cool, we got lucky. Because sometimes, you know, when they do that intermediate rounding, like usually we try to keep it exact and don't round until we get to the very end, right? Because if you start rounding early, then it gets thrown off. I think let me kind of glance at that last one. I'm a little bit like out of it. Let me pull this up. Suppose the temperature in degrees Celsius over a 10-hour period is given by this. Find the average temperature, find the minimum temperature, and find the max temperature. Okay. Okay, I'm just gonna, let me screenshot it here. Maybe I can just drop the image. Let me hit done. I'm gonna copy and delete. And I'm just gonna pull this one up here instead of pulling up the soft copy. All right, so it says, suppose that the temperature in degrees Celsius over a 10-hour period is given by this. Find the average temperature, find the minimum temperature, and the max temperature. Okay, so the average temperature is like what we've been doing, right? So for part A, we're gonna find the integral, First we need to do 1 over B minus A, 10 hours. So I guess we're going from 0 to 10. So we're going to say 1 over, it's going to be 10 minus 0, which is just 10, times the integral as t goes from 0 to 10 of this thing, minus t squared plus 8t plus 40 dt. Okay. So then this is going to be 1 over 10. That's going to be what? T cubed over 3. Negative t cubed over 3. T squared over 2. So then that becomes plus 4 t squared over, no, just t squared, right? And then plus 40 t. We want to evaluate this as t goes from 0 to 10. Okay. I think when we plug in 0, that second expression is gone. So we can just plug in the 10. Ten to the power of 3 over 3 plus 4 times 10 squared plus 40 times 10. Okay. I mean, I guess we can do it. 1 over 10. That's what, a negative 1,000 over 3. 400 over 1. So 4 times 3 is 12. 1,200 over 3. And that's another 400. So I guess you make it what? Just plus another 1,200 over 3. Okay. So what is that? 200 plus 1,200 is 1,400 over 3. So then that's 140 over 3. Looks like the final result is 140 over 3. And I think we can go with that. That's for part A, the average temperature. That's approximately, or you can say that's equal to that's a 4 with the, that's a 12, so that's a 26 with the remainder of 2 and 2/3. So 0.6 bar. And that's what, degrees Celsius. Okay. So notice that we have an upside down parabola. So there's going to be a local max. So the min we need to test the endpoints. Because it's upside down parabola, when it's at time 0, we're at 40. At time 10, that's what, a minus 100. Minus 20, we're at 20 degrees Celsius. Okay, so I think the minimum is 20, basically when T was 10. So for B, the minimum we got was 20 at 10 hours. Okay. 20 degrees Celsius. And so basically what I was doing, hopefully I'm doing that right. You know, it's an upside down parabola. It's a U-shaped curve that's upside down. So that means we have a local max. To find the minimum, we have to test the endpoints. When I plugged in 0, I got 40 degrees Celsius. When I plugged in 10, I got 20. And I know the max is going to be higher than that. So 20 degrees Celsius after 10 hours was my minimum. The max should occur at the vertex, which is going to be negative B over 2A. So negative 8 divided by negative 2 is 4. So after 4 hours, we should be at the max. So then when we plug in 4, let me see, 16, 32. So I think we're at 56 degrees Celsius.
Professor, are you using your calculator to graph the function?
I'm just looking at it because the highest powers are 2. Let me make sure these results are correct. But the highest powers are 2, so I know from there it's a U-shaped curve that's upside down because my leading coefficient is negative. So then it's a quadratic, right? So we're working with the quadratic. So then I use the vertex formula to find the max, all right? And then I also tested the endpoints of 0 and 10. So after 0 hours, the result was 4, or initially, when they started, the temperature was 40 degrees Celsius. After 10 hours, when you plug in 10, I got 20 degrees Celsius. And when I use the vertex formula, which is negative B over 2A, I got that the vertex of the parabola occurred when x was after 4 hours. And when I plug in 4, I got a result of 56, right? So that was a little bit of like college algebra. Let me make sure that these results work before I commit to this. Let's see, the average temperature, right? That's reasonable. It says type an integer or decimal, round to 1 decimal place is needed. So then 46.7 degrees Celsius. 46.7. That's not working for me. Let's get rid of all of this. How you not working?
Professor, I can't see you typing.
Yeah, I'm just doing it on my phone. Let me just check it here. 46.7. If I can get it to work properly, it's gonna throw in a tantrum. 46.7 is correct for part A. The minimum temperature we got was 20 degrees Celsius. So I'm just gonna type in 20 up. 20. 20 is correct. And the max temperature we got was 56. Yeah, so those are correct. All right, so these results are correct. Okay, I think I'm gonna call it a day. Okay, so hopefully you got something out of that. What's today? Today is what, Wednesday? So, just feel free to email me over the weekend. If I, have the time and focus and energy, I'll go ahead and make a dedicated video response. If not, we can talk about more of this on Monday. Okay, guys. So with that, are there any other burning questions before we go our separate ways? Okay. If there aren't any other burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, enjoy your weekend, guys. I'm going to go ahead and make a copy of the PDF of everything you saw me writing. I'm going to make a copy of it available to you on Blackboard. All right, gentlemen, enjoy your weekend. Take care. Peace.
All right, bye.
Mm-hmm. Let's see.